Okay, so here is some neutralization practice and some reminders about neutralization reactions. Number one, these are always going to be double replacement reactions, okay? Because it's always going to be an acid plus a base, okay? These will always be a double replacement reaction, all right? So in this specific type of double replacement reaction, when we add our acid and our base, we will always get the same products. Number one, we will always get water and a certain type of salt, okay? Now that salt doesn't always have to be NaCl, sodium chloride. That's just one type of salt, but we will always get water and a salt. When we go to balance these, if we need to balance them, it is often helpful to think of water as HOH. The reason for that is every single base will be some type of metal added to a hydroxide, okay? So we've learned a lot about bases in class. That's nothing new to us. The new thing is the base, and how do we recognize a base? It has a hydroxide on it. Things like ammonium hydroxide or calcium hydroxide or sodium hydroxide. All of those have hydroxide in them, so they indicate a base. Just a reminder, how do we know that we have an acid? Almost always it starts with a hydrogen. So things like hydrogen, hydrochloric acid, H2SO4, that hydrogen indicates an acid, okay? So when I go over here to do some of the practice, this is the homework on part 2. I need to be able to go from the formula into the reaction, or down here further, we have the words, the name of the acid into the formula, okay? And so we've done these in class before. We've just never put in the name of neutralization onto this type of reaction, okay? So to start, HI, that's binary, so it should be hydroiodic acid. So I have HI plus NaOH. Once again, that OH is showing us that we have a base, so I know that this is a type of neutralization reaction, acid plus a base. That will give me water plus, in this case, the salt is going to be your sodium and your iodine put together, NaI. Now, sodium has an oxidation number of +1, iodine has an oxidation number of -1, so when you cross those up, those will cancel out. So this is a good reaction. Now, if I were to balance this, I would look at balancing my hydroxides first. But looking at this, it appears everything is already balanced. Okay, so when I go to the next one, this looks like carbonic acid. Let me get my polyatomic ion chart ready to go. So CO3, yep, this is carbonate, so this is carbonic acid, H2CO3. I'm just going to rewrite this, is added to strontium hydroxide, OH, and that gives me, once again, this is neutralization because we have an acid added to a base. So I know that right away I'm going to produce water plus some type of salt. That salt is going to come from these two things when I do my double replacement. So it's going to be strontium carbonate there. Now when I go to check my ionic rules, strontium is a +2 and carbonate is a -2, which is a good thing. So when I cross those down, those should cancel out. Okay? So when I go to balance this, I notice that I have 2 hydrogens over here, a carbonate there, strontium, and then an oxygen. So this is already balanced as well. Okay? If we go to, let's go down to letter D, hydrobromic acid and barium hydroxide. So this is more like what you're going to see on a quiz and a test. We need to be able to go from the name into the formula. So hydrobromic Just a reminder, hydroamine is our binary system. So hydro, there should be one other element, be our hydrobromic acid is added to barium hydroxide. Now barium has a +2 charge, so this should be BaOH2. Right, a +2 here, hydroxide has -2. When we cross those up, that's to cross down, and that should be my reactant side. And over here, because it's an acid and a base, once again, I get water added to, my salt comes from what I have left over here, barium bromide. Once again, make sure your cation goes first, which is barium, your anion is second, which is bromine. Now once again, barium has a +2 charge, bromine has a -1, so when I cross those up, that is what I should get. So is everything balanced here? I have one barium over here, one over here. Bromines are not balanced, as you can see here. Okay, I also have 2 hydroxides, and if you remember up in this step where I told you that sometimes when we balance, it's easier to think of water as HOH. That way we can balance our hydroxides on both sides, because there will be a base, every base has a hydroxide, we can balance our hydroxides. So when I go back over here, when I do this, I can look at this as HOH. Okay, so now if I come out here, I have 1 hydrogen on the left side, I have 1 bromine on the left side, I have 1 barium on the left side, oh, there we go, and I have 2 hydroxides on the left side. Split this up. On the right side now, on my product side, hydrogen, I have 1 because now I'm thinking of HOH. I have 1 hydroxide, I have 1 barium, and I have 2, oh, here we go, 2 bromines, right? So what I like to do is I like to balance my hydroxides first, okay? So I have 1 on the right side and I have 2 on the left side. So when I come back over here to get 2, I'm going to put a 2 right here. But we notice that that now makes that 2 hydrogens right here, and I also have 2 hydroxides, which is a good thing. So now if I look, I have 2 hydrogens on the right side, I have 2 hydroxides, a barium, a bromine. So if I want to change this up, I'm going to balance my hydrogens. If I go over here and put a 2 in front of that 2 HBr, now that changes my reactant side, 2 hydrogens and 2 bromines. So now if I check, 2 hydrogens balance out, my bromines balance out, my hydroxides balance out, and my bariums balance out. So if I want to rewrite this to make it look nice and neat, and as you should on a quiz or a test, 2 HBr plus BaOH2 produces, now I'm going to change that hydroxide back into water simply by putting just H2O. Now, but I have 2 water molecules added to BaBr2. Okay, so the only thing different about neutralization is that we put a name to adding an acid to a base. All right, they neutralize each other to give us a water and salt, but this is a type of double replacement reaction.